Hi guys, we're going to continue our look at differentiation and come to something called the chain rule. So the chain rule helps us differentiate what you might call a function of a function. So for example, if I had y equals 1 plus x squared, I've got this inner function here, but then I'm doing something to it as well. So I've got an inner function of 1 plus x, but I'm doing a function of squaring on top of that. So the chain rule is going to help us with that sort of thing. So let's build our way up to it, and I'll have a look at this for a start, and I'll say, well, that means that y is equal to 1 plus 2x plus x squared. If I expand that bracket, and if I was to differentiate that, I would get 2 plus 2x, which is 2 times 1 plus x. And I might even say that that was 2 times 1 plus x to the 1. Now if I continue that and we look at y equals 1 plus x cubed, using the binomial to expand that, I get 1 plus 3x plus 3x squared plus x cubed. If I were to differentiate that, I get 3 plus 6x plus 3x squared, which is 3 times 1 plus 2x plus x squared, which is 3 times 1 plus x squared. So I think you can see that in this first case I've reduced that power by 1 and times by the old power, and here reduced that power by 1 and times by the old power, as you would expect with normal differentiation. So I have y, if I had y was equal to 1 plus x to the 4, then dy by dx I would expect to equal 4 1 plus x cubed. And that's great. But what about if I wanted to do y is 1 plus 2x squared? Well, let's go back to this first principle way here and say, well, that means that y is equal to 1 plus 4x plus 4x squared. And if I differentiate that, I get 4 plus 8x, which is 4 times 1 plus 2x to the 1. Now, if I'd have just reduced this power by 1 and then times by the old power, I would have had a 2 outside here, but I've got a 4. And maybe if I look at it like saying, well, that's 2 times 1 plus 2x to the 1, that might lead us a bit closer to the reasoning behind where the answer comes from. I'll try one more. Let's go for y equals 1 plus x squared. So that would be y equals 1 plus 2x squared plus x to the 4. So dy by dx is equal to 4x plus 4x cubed, which is 4x times 1 plus x squared. And I could say that that's to the 1. So that would be 2x times 2, 1 plus x squared to the 1. So reduce the power by 1 to make it a 1, times by the whole power to put a 2. That gives us that. We've been given that it's multiplying by 2x as well. In this case it was multiplying by 2. And what you'll notice about this is that is the differential of that, of 1 plus 2x. That there is 1 plus 2x differentiated. And this is 1 plus x squared differentiated. So you times by the differential of the inside of the bracket. So for example, if we have y equals x plus x cubed dy by dx, let's take that to the power of 4. So first of all, I differentiate the bracket as a whole. So I have x plus x cubed, now to the power of 3, but times by 4. But then I would have to times by the differential of the inside bracket, which is 1 plus 3x squared. So that would be 4 times 1 plus 3x squared x plus x cubed. So if y equals a function of a function, let me think how I'll put that. Let's go for, no, I'll complicate it if I go too far with the terminology. Let's just have a look at ln of cos x. So dy by dx, you would expect, if you were differentiating a ln, the differential of ln x is 1 over x, so you would expect to get 1 over what's inside the bracket, and you do. But then you need to think about what's the differential of inside the bracket. Differential of cos is minus sine x. So let's just label what we're doing. So differential of, I'm going to put that, say that's the inner function times the differential of the outer. So my answer would be minus sine x over cos x, which is minus tan x. So you differentiate ln, you get 1 over what's in here, but because it's a function of a function, you have to times by the differential of the inner function. Okay, so just to summarise, here you differentiate the bracket as a whole to make that 2, bracket to the 1, but then you multiply by the differential of the inside the bracket, so multiply by 2x, which is the differential of this, and that's why that comes about. Here you differentiate the bracket as a whole, so bring the 4 down and reduce the power by 1, which is what you've got there, and then you times by the differential of the inside of the bracket, which is what's there. And here, if we were to differentiate ln, we get 1 over, which is what is here, but you must times by the differential of what's inside the bracket, which is there. So it's always the differential of the inner times the differential of the outer. And if you look in your textbook, you'll see that that's written formally in all sorts of ways. But actually, if you just remember differential of what's inside the bracket times the differential of the bracket as a whole item, you'll get this and get it very quickly. Okay?